binary, which you guys already saw the other day when we did like the trick with the cards, right? So we're talking about converting denary, which you guys know as decimal, to binary. All right, and just to start out with an example here, if we took something like 13 and we wanted to convert it to binary, okay, 13 base 10, what we would do is we would start out by thinking about having to fill in ones and zeros in certain places in a binary string of values, okay? And then we would think about like this being the ones place, this being the twos place, the fours, the eights, and the 16s. And then we would consider where we should start, okay? So we didn't go up to 32 because 16 was already too big. We're not going to need a 16s place for this problem, so we're not even going to worry about that one. And what we might do after that is say to ourselves, well, we need to take 13 minus 8, which is 5. And since we took 8 away from the 13, that means that there was an 8 in the 13, and we're going to put a 1 there. Okay? And then we're going to think about, can we do 5 minus 4? So we can. So 5 minus 4 is going to give us 1. And so we have a 1 in the 4's place. And then we want to think about, do we want to do 1 minus 2? But 1 is smaller than 2, so we don't want to do that. So we want to say there is no 2 in there. All right? And then we want to think about, do we want to have a 1 in there? So we want to do 1 minus 1. That equals 0. We do have a 1 in there. And when we get to 0, we know that we're done. Okay? And so we could rewrite this and say 13 base 10 equals 1101 base 2. Okay? All right, let's do another example. So let's try 35. Okay? So again, I'm thinking about the place values that we're going to have to fill in, and I'm going to put some more in because that's a bigger number. But we want to go ahead and start at 1, and then we just multiply 1 by 2 to get 2, and times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, but we say, oh, okay, well, we don't need 64, so let's not worry about that one. Okay? And then we do the same process that we just talked about. So we're going to say 35 minus 32 gives us 3. And since I subtracted 32, I'm going to put a 1 over it because I used it. And then I want to think about, do I need to use 16? No. 3 minus 16 doesn't make sense in this case, right? We could get a negative number, but we don't want negative numbers in this case. So in other words, if the value down here is bigger than this value, we don't want to use it. So we want to put a 0 there. Same thing for 8. Same thing for 4. And finally we get to 2 and we say, okay, well, we can do 3 minus 2. That would give us 1. And since there's a 2 in there, we're going to put a 1 down there. Good so far? 1 minus, the next thing is 1, and we can do 1 minus 1. That gets us 0. So I put a 1 there to make sure that we keep track of the fact that there is a 1 in the 35. And 0, again, tells me that I'm done. Okay? And so I can put 35 base 10 equals 100011 base 2. Okay, that would be an answer. All right. So this method is called the subtraction method, this method of converting from decimal to binary. It's called the subtraction method. And what we're going to do right now is we're going to write out an algorithm that we could follow that describes how to do the subtraction method. Okay? So then after we do that, I'm going to go through another example of like actually following the algorithm. And then I'm going to show you a different way of doing it, which is called the division method, which some people like better. Okay? So I'm going to go ahead and turn the page over here so we can go through the subtraction method algorithm. Okay? So this is the subtraction method algorithm. All right? And before we go through the algorithm, let's kind of define some things that we are dealing with. So one of the things that we're dealing with is a decimal number, and we're just going to call it number. Okay? So that's the decimal number that we start with. That's what we're trying to convert. Then we have binary. Okay, that's the number that we're trying to convert to. All right. If you think about what's going on here in those last two examples, when we did like 35 minus 32, we got 3, and then 3 turned into my new number, right? And that told me to do something to the binary value, like add a 1. Okay, so we have to think about like when do we do those things, all right? 32 came from somewhere, right? 35 was the number originally. 32 came from somewhere. Just like 16, just like 8, just like 4, 2, and 1. Okay? So we got to think about what do we call those values? The values that we put under the place markers. Yeah. So, yeah, each of these values is a bit, but they have different value because of these numbers. These are place values, but what, like mathematically, what would you call this 1, 2, 4, 8? You'd call them what? Those are powers of 2. Okay? So let's go back to our algorithm here, and we're going to say that we have a power, and in this case, we're talking about powers of 2. Okay, so let's get started with this. The thing we're trying to find is binary, okay? And we're going to say binary starts out at 0. That's the beginning of the algorithm. Then we're going to say number, the value that we're trying to convert to decimal, is going to be input. Okay? So this is we're going to say input the value to be converted. And we're going to call that number. And then we're going to say power equals the biggest power of 2 that is less than number. That's a good point. So let's say less than or equal to number. All right? So then we went through a couple examples, right? And we said that we know that we're done with the process when the number reaches 0. Okay? And so we're going to start this out by saying while number is greater than 0, we're going to continue the process. Okay? And the process is this. We're going to take the number and we're going to make it equal to the number minus the power. Right? So this was like 35 minus 32 is 3. Now number equals 3. Okay? And when we do that, we have to change our binary value. Our binary value gets a 1 added onto it. And here's how you do that. You take your binary number times 10, and you add 1. Okay? So then, the next thing is to figure out the next power value. And it could be that we want to add zeros onto the binary value after that. So like we subtracted 32 from the number. That said that we had to add a 1, right? And then we didn't want to subtract 16, and we didn't want to subtract 8, and we didn't want to subtract 4, and then we did want to subtract 2. So there's a process going on there where we say while the number is still greater than 0, okay, and the power is greater than the number, right? So we said we're not going to subtract 16 because 16 is bigger than 3. We're not going to subtract 8 because 8 is bigger than 3, okay? So we're going to say as long as that's true, then the power is going to equal whatever the power was divided by 2. And here's the next part. If our number is less than our power, then our binary number is equal to our binary number times 10. So that's basically adding a 0 onto it. Okay? So then we're going to say, while that's true, we're going to repeat. So that means we're going to go back up to there, right? And this is another repeat that goes up to there. All right. And when we're done repeating that, we're going to go ahead and output our binary value. Okay? So this can be kind of confusing. So let's go through an example. And let's go through an example that we know the answer to. So we're going to do 35. Okay? So binary equals 0. So I'm going to go binary equals 0. Number equals input value to be converted. So number equals 35. All right. Power equals my biggest power of 2 less than or equal to number. So start at 1, 2, 4, 8, 16, 32, 64 is too big, 32 is my power. Okay? So then this says, while or as long as numbers greater than 0. So is my number 35 greater than 0? Yep. So then I do number equals number minus power. 35 minus 32 gives me 3. Binary equals binary times 10. 0 times 10 is 0, plus 1 gives me 1. And then it says, while number is greater than 0, 3 is greater than 0, so that's true, and power is greater than number, power is 32, that's greater than 3, then I'm going to do power equals power divided by 2. So now power is 16. 32 divided by 2 is 16.
So you have to keep doing it?
And if my number is less than my power, so is 3 less than 16? Yep. Then binary equals binary times 10. So 1 times 10 is 10. My new value for binary is 10. And this says repeat. So I'm going to go back up here and I'm going to check if this is still true. Is number greater than 0?
Yes.
Yeah, 3 is greater than 0. And is power greater than number?
Yes.
Yes, 16 is greater than 3. So then power equals power divided by 2. This becomes 8. And I check if number, which is 3, is less than power, which is 8. That's true. So then I'm going to do this. Binary equals binary times 10. 10 times 10 is 100. So now binary is 100. This says repeat. So I go back up here and I check whether this is true again. Number greater than 0, still true. Power greater than number, still true. 8's greater than 3. So power equals power divided by 2. This becomes 4. Number less than power is true. 3 is less than 4. So binary equals binary times 10. 100 times 10 is 1,000. Repeat. So I go up and check it again. Number greater than 0. Yep. Power greater than number. 4 is greater than 3. So power equals power divided by 2. This becomes 2. Is number less than power? Is 3 less than 2? No. So I skip that. I repeat again. Is number greater than 0? Yes. Is power greater than number? 2 greater than 3 is false. So that's not true. So then I skip all of this stuff because that wasn't true. Okay? Skip all this, and then I repeat going up here, and I check if number is greater than 0. Number is still greater than 0, so number is going to be number minus power. 3 minus 2 is 1. Binary equals binary times 10 plus 1. 1,000 times 10 is 10,000, plus 1 is 10,001. So this becomes 10001. Okay? Then I check, is number greater than 0? Yep, 1 is greater than 0. And is my power greater than my number? Is 2 greater than 1? Yep. So then I have to do power equals power divided by 2. So that becomes 1. And then I check, is my number less than my power? It's equal to my power, so it's not less than. I repeat, is number greater than 0? Yep. Is power greater than number? No, they're equal, so they're not it's not greater. So then I repeat this. Is number greater than 0? Yep. So then number equals number minus power. Okay. So now number is 0. Binary equals binary times 10 plus 1. So this becomes 1000011. And then I check, is my number greater than 0? No, because it is 0. So then that skips all of that stuff. I don't repeat. I go up here, I repeat to check if number is greater than 0. Is it greater than 0? No, it's equal to 0, so I skip all of this stuff, and I output binary. So the thing that I'm going to output is that value. Okay? So, what you can maybe take from this, right, is knowing a process is different from like writing out a process. I think this process is kind of hard to write out. Okay? So if you looked at it and you're like, wow, that's a lot of work, you're right. Okay? And I didn't get it right the first time or the second time or the third time. Okay? And I've been doing this for a while. So I had to make a couple iterations of this, and now I think it's a good one. And even while we were doing this, you know, Trell pointed out here that we need to put or equal to. I didn't have that originally. Okay? So writing an algorithm is difficult. I'm going to show you now the division method, and then I'm going to ask you guys to be able to use the division method and try to write your own algorithm for it. Okay? So let's take a look at the division method. All right. So before we do the division method depends on us dividing our number by 2. Okay? So let's think about this. If we start with the number 77 and we divide it by 2, we get a value, right? So let's go ahead and figure out what that value is. So let's go 77 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. 2 goes into 17 8 times. 8 times 2 is 16. 17 minus 16 is 1. So we have a remainder of 1. So the way that we're going to write this is 38 remainder 1. So this value over here, what do we call this value? Not 1, but we call it the, we just said it a second ago, the remainder. Okay? So that's the remainder. Remember when we defined number, binary, and power, right? So we're doing the same thing here. We're saying remainder. This number, and this number. Anybody know what any of those numbers are called? Which one is the quotient? 38 is the quotient. Anybody know what 77 and 2 are called? This one is called the dividend. And what's the 2 called? The divisor. Okay? Here's how it works. Yep. Here's how it works. We're going to take 77, and kind of like we did it over here, we're going to divide it by 2. Except what I'm going to do is I'm going to flip the dividing sign upside down. So it's going to look like that. So 2 goes into 77. We already did the math, so I'm going to just put down that it's 38 remainder 1. Okay? And then we're going to keep doing that. So we're going to repeat dividing by 2. 2 goes into 3 one time with 1 left over. 2 goes into 18 9 times with no remainder. So remainder 0. So we get 19 remainder 0 there. We're going to divide that by 2. 2 goes into 19 9 times. Remainder 1. 2 goes into 9 4 times. Remainder 1. 2 goes into 4 2 times. No remainder. So remainder 0. 2 goes into 2 1 time. Remainder 0. And 2 goes into 1 0 times. Remainder 1. Okay? And when I reach 0, that tells me I'm done. The binary value of 77 then is the remainders that I found when I did my math. Okay? This is the leftmost digit or bit, and this is the rightmost digit or bit. So we go from the bottom to the top, left to right. So we can say 77 base 10 equals 1001101 base 2. And that would be our answer.
That's weird.
Does the process make sense?
Mm.
Okay, so I want you guys to try one on your own here.
Wait.
Yep, I got you. It's hard to take a picture of a process. Okay, so if I give you 100 base 10, can you find the binary value using the division method? Okay, go ahead and try that right now. All right, so let's go over this example. Okay, so we're going to go 100 divided by 2. That gives us 50, and we got a remainder of 0. If this number is even, my remainder is going to be 0. If the value is odd, my remainder is going to be 1. Okay, so 50 divided by 2 is 25, right? Remainder 0. 25 divided by 2. Now we have an odd number. If it was 24, it would be easy to say that 24 divided by 2 is 12. But because it's 25, we get 12, but we get remainder 1, right? 2 goes into 12 6 times, remainder 0. 2 goes into 6 3 times, remainder 0. 2 goes into 3 1 time, remainder 1. 2 goes into 1 0 times, remainder 1. And that tells me that I am done. And then I work my way back up. This is my leftmost, all the way up to my rightmost bit. So 100 base 10 equals 1100100 base 2. Okay? Quick way to check your work. All right? So we're going to check this. We're going to start at the rightmost bit, and we're going to put down that that's a 1, 2, 4, 8, 16, 32, 64. But we're only going to worry about the ones where there's ones. So 64 plus 32 plus 4 better equal 100, right? 64 plus 32 is 96, plus 4 is 100. So since that sum is 100, we can check that off. If you want, you can say, like, we don't use these because there's zeros over there. So 64 plus 32 plus 4 equals 100. Good enough, guys? All right.